Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Dan Lynch joins me. We're going to talk about Cassandra, the high-performance NoSQL database that may be powering some of the websites you're already visiting. You're going to want to see this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by Cachefly at CACHEFLY.com.
This is FLOSS Weekly with Randal Schwartz and Dan Lynch. Episode 183 for September 21st, 2011. Cassandra. This episode of FLOSS Weekly is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com, bringing you each week, or as often as I can make it here, the great projects, the small projects, the projects that are running the websites you probably visit every day, the projects you might never have heard of, the interesting people, the clever people, and maybe even sometimes both the clever and interesting people. I am just back. Sorry I missed last week, but I was busy on a cruise. But I am back in full force. Talk more about the cruise at the end of the show. But right now, what I want to do is get right to seeing and introducing, bringing back our co-host, Dan Lynch. Welcome back to the show.
Hi, great to be here.
Very good, Dan. It's been so long since we've chatted. What, a couple of weeks? I think you were the co-host a couple of weeks ago, and now you're back again.
That's right, yeah. And I don't know if you'll be able to see, but I've actually moved my studio in that time as well. So I'm in a different room now. Although all the rooms in my flat seem to just contain bare white walls, so you would never know the difference. But there is a window just over my shoulder now that you never used to see before.
Okay, well, and I'm still in the same room here at Media Temple. Thanks for providing both the giant mic to my left. It is to my left. Yeah, to my left. And, of course, the mugs and the free tea. The free what's the name of the tea? Something tips?
PG tips.
Yeah, PG tips. So Postgres tips available right here in the little mug. Okay. Well, the show's not about us necessarily, although we're the ones sort of asking some of the questions, but our show really is about the people that we have on, the guests that we have on. This week, very special guest. I say that every week now, but this week, very special guest. Jonathan Ellis is the project chair of the Apache Cassandra project. Cassandra is one of those NoSQL databases. I know we've had a bunch on like Mongo and React and so on, but I think this one's got an interesting twist, mostly because it was built to solve some really high-performance problems at Facebook. And I understand it's also used in a lot of interesting parts of like Twitter and a bunch of other large websites that a lot of our audience probably visits every week. So we're going to ask him about Cassandra and how it all came about and how it fits together, and also what NoSQL means again, and see how to deploy Cassandra and how to bring it online. Dan, what do you think about? Have you looked at Cassandra before, and what do you think of it so far?
Yeah, I've actually, I have to confess, I've been doing a lot of research on it in preparation for this show. I hadn't used it a lot before that, but a lot of people I know are very excited about it. And as you said, the more you look into it, the more you realize that most of the sites, or not most, certainly a lot of the big kind of high-performance sites that we use are using Cassandra somewhere in the background, so they must be doing something right.
Well, great. So we're going to bring on Jonathan in just a minute, but before we do that, I have a brief message to bring to you. If I can double-click real quickly here we go. So this episode of FLOSS Weekly is brought to you by Netflix. Netflix streams thousands of TV episodes and movies directly to you, instantly, which means you save time, money, and hassle. There are several easy ways to instantly access streaming movies and TV shows with Netflix. You can watch Netflix movies and TV shows on your Mac or PC or iPad. I have a Mac laptop, and I was watching last night in the hotel room. I was watching the show Louis. I love Louis C.K. as a performer on stage. I didn't realize he had a series, and then it comes up as one of the new things available on Netflix. So I'm really happy that now I can go back and watch the old episodes. You can watch on your iPhone and some Android phones as well. I watch on my iPhone from time to time. And if you have a gaming console like an Xbox 360, a PS3, or a Nintendo Wii, you can watch Netflix right on your TV. My PS3 works just fine for that. Full 1080p resolution, all really great stuff. And if you're not a gamer, you can watch Netflix on your TV with an Apple TV box or a Roku box. I have the new generation Roku, and it's full 1080p. It looks brilliantly beautiful. It says they're inexpensive and easy to use. With Netflix, you can watch movies and TV shows instantly using any of these devices. And as you begin watching a movie or show on one device, then finish on a different one. Whichever way you choose to access Netflix, you can watch as many movies or TV shows as you want, anytime you want. And you can cancel at any time. So try Netflix today for 30 days free. Go to netflix.com/twit. That's TWIT. Be sure to use this URL when you sign up for your free trial, netflix.com/twit. And we thank Netflix for their support of Twit and Floss Weekly. And we hope you enjoy watching instantly with Netflix. Having said that, let's go ahead and bring on our guest. Welcome to the show, Jonathan.
Thanks for having me on, Randal.
Cool, cool. And where are you speaking to us from?
Well, I'm actually speaking to you from New York City right now. I'm out here for the Strata conference, but my home base is Austin, Texas.
Oh, very good, very good. And Strata is a conference, I guess, related to the thing we're going to talk about today?
Well, it's related to scalability and high performance, so yeah.
Very good, very good. So I gave sort of an overview of what I already understand about Cassandra from just reading the voluminous information you forwarded to me, and a little bit that I knew sort of from previous conversations about it. But I'm sure I didn't do it justice. So why don't we first step back and describe the problem that existed at the time that Cassandra was created to solve, and then describe how Cassandra helped solve it.
Well, so the problem that businesses have been dealing with for the past 10 years has been that traditional relational databases don't deal with scaling volume of data or scaling volume of requests very well. And so particularly as you have high traffic websites or software as a service model, these things tend to require both of those high data volumes and high request volumes. And so one of the pioneers of dealing with this problem was eBay. So, early on, they were outgrowing their ability to scale vertically by just buying bigger and bigger hardware to run Oracle on. So once they outgrew the biggest Sun boxes they could buy, they started sharding their data across multiple machines. And so what people found, so this is not rocket science. It's not something we don't know how to do. But when you start to do this, you lose the advantages of using a relational database. It's not meant for that. You can't have foreign keys across shards. You can't do transactions across shards. You can't do joins across shards. So people looking at this problem said, let's reinvent this. Let's build something that gives us advantages to make this problem easier, this problem of distributing my data across multiple machines, to make up for what I'm losing, these ACID base that we've had with a relational database for so long.
And so how did the Cassandra project get started from that? So
the Cassandra Genealogy comes from two proprietary projects. Google's Bigtable, they published a paper about that in 2006, and Amazon's Dynamo, which was also a research paper published in 2007. And Google's Bigtable focuses on the data model of building a distributed database. What is simple rows and columns the right model to go with, or do we want to do something more, something that helps us deal with not having joins in particular is the problem they were addressing. And what they came up with is what they call the column family model, where you have rows and columns, but it's not just a static set of columns that you're dealing with, but also you can have millions of columns in a row, columns that you create at runtime. And you use this to basically build materialized views to, again, make up for not having joins to compute that at runtime. And then on the Dynamo side, the problem they're solving was dealing with high availability and replication to deal with failure. And so Cassandra takes the replication model of Dynamo and the data model of Bigtable and puts those two together. So as you mentioned, that was open sourced by Facebook in 2008, and I got involved at Rackspace. They needed a scalable database, and we got it into the Apache Foundation and went from there.
So obviously, people have been using, the traditional. I'm pretty sure, like the airlines using traditional RDBMSs, traditional like big installations of Oracle and stuff. What's unusual about the kinds of things that eBay was facing that wouldn't just let this part of it scale?
I don't know the details of the differences between what airlines are doing and what eBay's doing, but my guess would be just the volume that you're dealing with. In particular, eBay has that auto bidding model, so you can have hundreds of bids per second without any user input. They're just auto generating bids. So that probably had something to do with it. Just guessing off the top of my head.
Yeah, it's probably transactions per second now that I think about it, because it just seems to be a lot more stuff going on the web with all this consumer data hitting the end databases directly. I notice that, when I'm at the airport, it does take them a couple of seconds sometimes to get back my response, or they'll go, oh, no, that seat's already taken. I got to try another one. They always seem to be typing like a little novel there. I don't know. I'm just asking for a simple seat move, and they're going type, 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 type. Maybe they're typing a little novel about, he's standing in front of me, and he's wearing this shirt. I don't know what it is. Anyway, sorry, I'm getting distracted because it's a great side thing. So so this is another member in the family. Then we've had people on like React and MongoDB and other things. I think we want to start out pretty early and kind of describe, how does this position itself against maybe some of the other things that we've had here on FLOSS Weekly?
That's a good question, and I think it's basically a combination of what I mentioned just now, that you have both the powerful data model and the high availability replication model. Something like Riak started off as more of a pure Dynamo clone. So they have they're based on the same kind of replication design that Cassandra is. So the advantage that Cassandra has over Riak is that Riak is still a key value store under the hood. And so you get by using the Cassandra materialized views, you can make your queries much faster at runtime, much easier. The other advantage over something like Riak is that Cassandra is built on the JVM instead of on Erlang, which gives it, from what I've seen, roughly 5 times as much performance. And then on the other side, you mentioned MongoDB, and that's kind of coming from the other direction, where it's actually not really it's kind of its own beast. It's not from the Google Bigtable family or the Dynamo family. It's its own beast. But what you see with that is that its distribution model is built around masters and not slaves, but masters and replica sets. And so you have if some of these master machines go down, then you have to fail over and hope the failover goes well. And if the old master comes up and thinks it's still the master while the new master is going off and being the master, then you get messy things. So it's not really a high availability design.
Okay. And so let's get back a little more concrete for people here, because I'm also getting my head lost in a lot of the terminology. So if I have a Cassandra installation, what do I actually have? Is it a bunch of machines all talking to each other? And can I pick for my application any one machine to talk to and it's equally good? Or is there like a central guy I got to talk to first before I get to anybody else?
Yeah, so if you have a Cassandra cluster, it's a fully distributed peer-to-peer replication model, and it chooses replicas for a given row based on consistent hashing. So all the machines in the cluster know where each row belongs. And so you actually can, as you said, you can connect to any machine and it will route the data correctly. Even across data centers, it generalizes to that very well. Now, what you can also do, it also supports, if you want to skip that extra latency, it also supports smart clients that also know about the replication strategy and connect to the right nodes, on the client side. It supports both models. It kind of encourages using the dumb client model a little bit more. That's kind of where we started historically, but it does support both.
Now, so now as the application developer, I then connect up to one of the servers, and so I've already previously laid out now they're not called tables, right? It's column, what do you call them? Column clusters?
Families, yes.
Column family. Is that close to a table though? Can I think of it as a table?
Yeah, you can kind of think of it as a table on steroids. You can define metadata on columns and say, so it's not an entirely schema-free database, which something like Bigtable started out as, but it's kind of schema optional. So you can have a user's column family and have a first name, last name, email address, and so forth, and then define those that, these are strings, my birth date is an integer, and the reason we want to do that, to add that metadata, is for the same reason that you have that in a relational database, or one of the reasons, is that you're going to have heterogeneous systems talking to the database. Your database is kind of your source of truth. So you want to be able to introspect it, to get information on what's in there, using data browsing tools, using Python reporting script, to interact with data generated by your Java web application. So having that data there, or the metadata about your column types, makes it easier for those different components to interact with each other. And of course, it also allows Cassandra to do things like, if you say that a column's a UTF-8 string and you give it a series of bytes that is not a UTF-8 string, then it can reject it and keep your data matching what you said it should match.
Okay, so I'd set up sorry, go ahead.
So far, what I've described is similar to a relational, schema. The difference is that when I go, and this comes down to how the storage engine works. When I go and say I want to add a new column to my users table, maybe I screwed up and I was using plain text passwords to start with, and now I'm going to go with bcrypt, and so I'm going to add a new column for my bcrypted password. I don't have to go through and reallocate space for each of those rows in a B tree, pages. I can just start using that new column immediately, and the storage engine will basically assume that the rest of them are nulls. The older rows have nulls for that column, and I don't have to spend a day or a week. I have a friend running a system that's partially based on MySQL. They had to do an alter table on one of their largest tables, and it ran overnight, to just finish that alter table. So you don't see that in Cassandra. And then the other thing that having that dynamicness gives you, as I mentioned earlier, that you can build kind of materialized views out of these rows. So what you can do is, instead of saying, I'm going to have such and such columns in my row, and I see that my face is frozen on screen. Do you still have audio?
Yeah, go ahead.
Okay. So instead of saying I have specific user and birth date and password columns, instead of specifying the columns like that, I can say that my column names are going to be integers and the values in the columns are going to be strings. And then I can do that. What I can do with that is say, for instance, all the tweets of people I follow, to use a data model of something we're familiar with. The tweets of people I follow are going to be in that row. So when I say, show me my Twitter timeline, I just have to go to a single row and pull out the first 50 columns or the last 50 columns. And I don't have to do any joins. I don't have to do any computation. It's already pre-computed in that row for me.
Yeah, I was just going to ask the model. I mean, typically, I've done a lot of RDBMS stuff, and so like if I have a like a person, I have a record for a person, they might have multiple phone numbers, and we would normally do that by doing some sort of foreign key to a table of just the phone numbers and whatever associated information is with each of those. Or address is probably more likely because lots of columns involved with that. So you're saying that I could do this in Cassandra simply by having like sort of a collection of columns that are related somehow, that are all basically have, in my mind, have the attribute of address.
Right. And so there's the two ways to look up data once you have it in that model are to either access it by row key, which is what I described with the materialized view aspect, or to look it up by a column value. So I can say, give me all the users whose state is Texas, and look it up by an index on a value like that.
Very good. So as I'm designing the database, then I have to think about the kinds of queries that I would be doing, and that would create the column groups or column families to put together.
Right.
And I'm also, as I'm sending it to the database, I'm also asking it to be replicated. Is there a typical value for how many copies, or just depend on my business model?
It depends on what you're trying to get out of the replication. Mm-hmm. You might be replicating because you can't afford to lose data, or you might be replicating because you want to have copies in more than one data center. If I have data centers on the East Coast, the West Coast, and Japan, maybe I'll just have one copy in each data center. Or I might say, well, I want to be able to tolerate local failures in the data center without having to add latency to my users and go get the data from a different data center. So I might have 2 copies in each data center if I'm doing it like that. Or maybe I just have a single data center in San Francisco, but I still want to make sure I never lose data. So I'll say, well, I just have this single data center, but I'll generate 3 copies of it. So it's very flexible on how many copies you want and where you want to put them, and lets you have the full power of determining that.
Okay, and so I know that one of the features I really liked about React was the ability that when I was reading stuff, that I could say, I want to make sure that, if I have 5 copies, I want to make sure that all 5 copies absolutely agree, versus say, for maybe a summary or a roll-up page or something, it would be just like 1 or 2 copies. Is that also available in Cassandra?
Yes, and I don't know the details of React, but in Cassandra, you can specify that on a per operation basis. Mm-hmm. So you can say, and you typically don't say I want all the copies to agree, because then if a single machine is down, then you can't do that. Some of your data will be unavailable, and it'll say, I can't check if this copy agrees because that one's down over there. But what you'll often do is you'll say, I want a quorum to agree. I want a majority to agree. And so That's one of the reasons why 3 is a popular number of replicas, is that quorum of 2 is still 2. So saying I want majority of 2 doesn't actually give me any fault tolerance. But once I go to 3, then I can lose a machine and still achieve quorum.
Okay, and then, and actually the example I used with the React guys was that if I have, for example, an airline seating application where I'm trying to figure out how many airline seats, the summary number that might be sort of in just picking their general flights, and it says 17 seats, it says 12 seats, would come from, say, only asking for a low replication number. And then if you actually drill down to that plane, then you absolutely need to know which seats are available in that plane, and then you'd ask for a high replication number. And that's just similar to what you do with Cassandra then, right?
Yeah. At the risk of getting into too low level, what you'd actually need there is when you go to book the flight, you'd actually either need to do a lock or a compare and swap operation to make sure that even if we're agreeing, we're not having a race where 2 people say, oh, there's 1 seat free, and everyone agrees that 1 seat's free, and so then I go do a write and both try to claim the seat. So there's a little bit of subtlety there.
Okay, great. So I deploy this. Oh yeah. And the one question I was sort of looking at then is, suppose you have a cluster of nodes in New York and a cluster of nodes in California, and and you lose connectivity between the 2 locations. Does it? If people are updating things on both sides, are they? What happens when it reconnects?
Well, that depends on how you've set your consistency levels. So you could say that I want to not accept any writes unless I can write to a majority of my replicas, in which case it will fail the writes and say, hey, you can't do this until those other machines come back up. Or you could just say, I understand that there's going to be a reconciliation when the connectivity is restored, so I'll go ahead and keep doing writes while they're down and synchronize those later. And either of those is okay. We actually see that in our, and when I say our, I mean, in my role as CTO of DataStax, our customers have probably about 60% of their operations use consistency level 1. And then the rest use either consistency level quorum or local quorum, which means a majority of replicas in the local data center.
That sounds very cool. We actually have a question related to this from the chat room, from the IRC channel. Tyrone King was asking in there, and you may have actually kind of answered this already, Jonathan, but he was talking about, he's been reading some comments by Adam Lowry, who apparently was unhappy with MongoDB and some of the things in Cassandra to do with fault tolerance when writing. Can you address that at all? Have you heard any of those criticisms, or how do you handle that fault tolerance when writing? I think you may have kind of covered that a little bit there.
Yeah, so Adam gave a talk, I think it was yesterday, but it was really recently about, the Hacker News title anyway was From PostgreSQL to NoSQL and Back. And it wasn't 100% clear from the slides, because he did say some things like we had these problems with Cassandra, but Urban Airship is still using Cassandra and, happy with it to the extent that, nothing's perfect, but it does the job that they want it to do. And I actually worked with some of the Urban Airship engineers on the problems they were having with Cassandra. And I guess the summary is we addressed the problems. And yes, they did find some legitimate bugs. And some of them were just dumb, right? Like in one place we were allocating an 8 megabyte buffer to do writes to the file system. And it's like, why would you do that, right? That's just going to cause garbage collection contention when you do that. So, but that's kind of the, that was, almost a year ago. So they got involved fairly early on. And, there were some rough edges. That's definitely true. But I think they're pretty happy with it now.
Okay, that's cool. I mean, every piece of software has rough edges and bugs. I think we can forgive I think we can forgive you that. So I was doing some reading up on Cassandra today, actually, and I was intrigued about you've talked already quite a bit about your fault tolerance and stuff like that, but you built around the kind of the assumption that hardware can and will fail at some stage. I was reading about your let me see if I can pronounce this right, accrual failure detector. Can you tell us what that is and how it works?
Yeah, so I can give you the high level. The expert on that is actually a guy named Brandon Williams. But at a high level, what that is a way to be more sophisticated about whether one of my peers is down than just a simple heartbeat. So, one of the obvious ways to say, if I have a distributed system, I have 100 machines in my cluster, and I want to know, is machine X down? One of the things I can do is just broadcast a heartbeat, and then I can have something in my software that says if I haven't heard from this 1 second heartbeat in 10 seconds, then he's probably dead. And so I'm going to assume he's down. I'm not going to try to read from him until I start getting those heartbeat messages again. So the accrual failure detector is a more sophisticated way to handle that problem, where it keeps a window of how fast those 1 second heartbeats are arriving. And if it starts to see heartbeats, every 1 second to 1.5 seconds, it adjusts that because it says, okay, there's probably some, the network is saturated, or maybe even he's CPU bound doing other stuff, and it's hard for him to get enough time to send out that heartbeat. And so I can adjust to that to accommodate that and say, okay, he's alive. I haven't heard from him in quite as recently as I expected, but I saw this choppiness happening, so I can adjust for that and not be as simple-minded about, I have a 10-second cutoff period. So it's basically just a more sophisticated way to address the failure detection problem.
Sorry, I muted my mic there. That sounds very cool. So, yeah, that's my own fault there, user error. So, Randal, do you want to hop in?
So, Jonathan, I'm actually sort of curious now. So did this actually start as a project called Cassandra within Facebook, or was that just how they pulled a couple of things together?
I'm not sure I understand the question. As far as I know, though, it's always been named Cassandra inside Facebook as well.
Okay, and so they were using some other, like probably MySQL databases, and then it sort of ran out of steam?
Yeah, in particular, they built Cassandra to run inbox search, and Facebook is still a huge MySQL shop. Most of their data still goes into MySQL. Basically they're in the position of, we have something that works. Our ops team knows how to deal with, the rough edges that has. So, there's no pressing need since we've kind of solved it by partitioning MySQL. Twitter is another social service using Cassandra, and they're kind of taking the same approach where, they're saying, our main tweet storage, before we started using Cassandra, we already got the problems with MySQL sharding figured out, so we're not going to mess with something that's working, but we are going to use Cassandra on our new projects and use it that way.
Very cool. And how did you get involved? Were you there from the beginning, or did you come along in the middle somewhere?
So I got involved when Rackspace hired me to basically build them a scalable database. As you probably know, Rackspace has been moving more into the cloud, and they recognize that as they're doing that, they need to have the kind of infrastructure that someone like Amazon, someone like Google, they're playing with the big boys, right? They need that kind of technology as well. And so I was tasked with that. And so I evaluated the options at an open source level because, Rackspace recognized that, they didn't want to build something proprietary and reinvent that wheel. They wanted to leverage the advantages of open source and working with others and kind of combining forces. And so I looked at the options, and Cassandra at the time had no real community. Facebook had open sourced it, but had no interest in running it as an ongoing project. People would submit patches to fix bugs, and they just kind of went nowhere. So I recognized that as a liability, but decided that I'd rather start with whatever had the best technical foundation and work on building the community from scratch if I needed to. And so I started maintaining a Cassandra tree with bug fixes, with new features. And Facebook's kind of last gasp of involvement was to get the project as a whole into the Apache incubator. And I became the first outside committer, outside of Facebook committer on that. And then when we graduated, I became the project chair. So Facebook's attitude was kind of, it does what we need it to do. We're moving on to other things. But the community has been driving it since then.
Now, is Facebook still grabbing the stuff now from, I guess, would effectively be downstream? Are they still like incorporating latest releases back in their production, or are they just frozen at their level when they released it?
Basically, they froze with what they had, and they'd been in production with it for a while at that point, and so they're like, we don't want to risk any regressions. Especially early on, we were breaking backwards compatibility with our first couple releases. So they weren't interested in going there. Today, Facebook does more with HBase actually than with Cassandra. They basically they hired a bunch of Hadoop people, and that was kind of the natural direction for them to go with.
Cool. And what's the relationship between Cassandra and DataStax?
Well, we're all about Cassandra. So we employ the engineers who are. I hate to say doing most of the Cassandra work, because a lot of, Twitter has people working on Cassandra, Netflix does, Rackspace does, but we have people full-time on it, and we're doing a lot of work on it, let me put it that way.
And you're providing essentially value added on top of what is a community edition, or is it, is there a different product you're offering that's based on Cassandra?
Boy, it's almost like I coached you to say that. Actually, that's good timing, because today we announced DataStax Enterprise and DataStax Community Edition, which are kind of our value-add distributions. Both of them come with our product called Ops Center for managing Cassandra clusters and tracking performance. And DataStax Enterprise also comes with analytics integration, and we have a roadmap to add more features for integrating features that the enterprise is interested in.
And so how do those products differ from what I would get if I just downloaded Cassandra from Apache?
Well, so at the technical level, DataStax Enterprise integrates kind of a custom Hadoop. So the core Hadoop map reduces there, but we run the job tracker in the same JVM. We run the task tracker in the same JVM. So it dramatically simplifies installation, and also gives you a higher degree of reliability over traditional HDFS-based Hadoop that has the name node that's a single point of failure, and scalability issues along with that. We also wrote a Hive Metastore that's based on using Cassandra directly, so you don't have to worry about maintaining a separate MySQL server for your metadata there, or Derby, or whatever else you could use there. So it's a combination of improved reliability and improved integration, I'd say.
Okay, and so, but is the community edition then the same as what I'd get from downloading from Apache, or is there also some value added there?
Well, I don't want to rule out the possibility of doing more with Community Edition, but right now it's basically Apache Cassandra with DataStax Ops Center for like I said, the cluster management and so forth.
Okay, and you have like an AMI available, so I could set it up easily in the cloud?
We do, as a matter of fact.
And that's only the professional edition, right? Or is it also the community edition?
Oh gosh,
good questions, huh?
So right now, as of today, the DataStax Enterprise and Community are officially going to be available in Q4. But as of today, what you can get right now is an AMI that has Cassandra plus Ops Center. So basically what's going to be Community Edition, only an earlier version of both of those pieces of code. But you can get an AMI with that and try it out easily.
Now, if I don't want to do it this way, I just want to build from source, what tools do I need on top of downloading all the source? So it's written in Java, you need Java compilers, right? Mm-hmm. What else do you need?
Well, if you're going to really, if you're developing Cassandra, then the main other piece you need is the Thrift compiler, because our client API is built on the Thrift RPC, which is also a Facebook technology. But if you're just saying, hey, I want the Cassandra source and want to poke around on it, but I don't necessarily want to build my own releases, then you don't need the Thrift compiler. We give you a jar with the code pre-generated for you. So it's basically you need Java and Ant and Subversion.
So do you have any of the stuff packaged for any of the major Linux distros?
Yeah, we have packages for both Red Hat distributions, basically Fedora and Red Hat Enterprise, and for Debian based, so Debian and Ubuntu, those are commonality. Our RPMs don't work on SUSE, so it's RPM based, but not really the same design as Red Hat based distributions. But yeah, most of the demand's been for Red Hat and for Ubuntu.
Okay, yeah, that makes sense. I was curious about. I was having a look at your last release, which was 0.8, I believe, earlier in the year, and you added a query language to it, which you're calling CQL, Cassandra Query Language, I presume. So how's that different from SQL? Because and is Cassandra still a no SQL database? I suppose now it's a CQL database, is it?
Yeah. So one of the Cassandra developers named Eric Evans was the primary driver of CQL, and he's given a talk called "You Got now it's not NoSQL, it's MoSQL with an M." But yeah, it's basically a subset of SQL that gives you access to the common parts, that they're both rows and columns, but doesn't give you joins, that the things that Cassandra by design doesn't do. Right now it also doesn't do other things. It does do count, right? So you have one aggregate function, you can do count. So we're not ruling out doing more of that. But right now, there's not really any aggregation. There's no group by, that sort of thing. So that could come, but the joins, it's fundamentally, you can't make distributed joins efficient. So that's the main difference of CQL versus SQL is that we're not going to be doing joins. We're not going to be doing subqueries. It's basically going to be a select from where kind of language.
Okay. And is this something that the users have been interested in? Because I'm curious to know how people manage when they've come from, a very strong kind of SQL background and so on. Do they have trouble adapting to this kind of database? Do you think that will help them to kind of find their feet, maybe?
Yeah, and one of the big wins is that it gives you commonality across, what you can do with your application and what you can do when you're troubleshooting your application, right? So before we had CQL, we had a command line shell that was, its own, built with Antler, its own grammar, just kind of ad hoc conglomeration of actions that you can do. And then when you'd go to say, okay, well, I can get it to work in this command line shell, now I go and I put it into my Python code, well, I have to rewrite that as Python queries over Thrift. It doesn't look anything like what I was doing in the command line. So with CQL, you can have the interactive command line, and then you can go and paste that into your program and have them work the same way.
Earlier you said that you were building this for Rackspace. Was this because Rackspace wanted to offer their customers a new data storage model?
That idea floated up while I was, so I left Rackspace a year and a half ago, so with the caveat that my information's that old, but that idea came up every once in a while, but really the main motivation was to be able to use it internally.
So to be able to provide the infrastructure, you have to keep track of a lot of different moving parts, and this would be the easiest way to do that. Okay, that makes sense. Working here at Media Temple, I see a lot of this going along, that there's a lot of internal data that's now in very, very badly organized MySQL tables with lots of legacy columns and stuff. We have one table that has like spare 6, spare 7, and spare 8. It's a traditional problem when you have MySQL. And actually, I wanted to address that from earlier when you mentioned this. It's a traditional problem when you have a database that doesn't have a way to do an alter table on the fly, like Postgres can do. You have to actually shut down your database when you have any tables being altered. I know, for example, Identica was down for like 3 or 4 days while they were doing an alter table, and it was really a mess. And I like the fact that you said that Cassandra can kind of do this on the fly. Can you give it, when you're doing that sort of adding to the column families, can you give it a transition rule so it wouldn't necessarily populate with nulls?
No,
Okay.
and there's that actually falls out.
No.
Yeah, so that's the short version. That falls out of how the replication model works. That we don't want to have all the replicas take out a distributed lock to make sure that they're doing things at the same time. So by just saying it's always null if there wasn't anything there before, then they can all apply those updates independently.
And how well do you handle updates in the sense of if I wanted to build a web page hit counter because I'm still stuck in 1995, and I just wanted to have it increment 1, 2, 3, 4, but it had to be accurate and consistent. Can you fetch the current value and put a lock on that row and update it later and make sure you've got the right number?
So there's a short version and there's a long version here again. We try really hard to avoid things that require locks because locks don't scale.
Right.
Even if you're using something like Zookeeper to do a distributed lock manager, then you still have you have to take out a lock. You're doing a Zookeeper update, and updates have to go to all the replicas. So there's I think 4 round trips basically to take out a lock. So that's going to max out at a few tens of thousands of locks per second you can do. So what we do in the case of counting in particular, what we've done is introduce a specific feature for that, a distributed counter feature, so that you don't have to do a read, update, write operation. You just tell Cassandra increment by X, and it takes care of doing that in a race-free manner that doesn't require locking.
Okay, so I might not want to run a banking application using this because that requires a lot of cross table and cross accounts locking and transaction management. But for something like, say, recording the tweets that come in or recording, the Facebook posts or whatever, although they're not using it for that, this does seem to be a pretty powerful and scalable system. Do you have any sense of what the largest installation would be? You don't have to mention the name, but like how many nodes they might have, how many nodes in the clusters they might have?
The largest one I know of is they actually did a press release about it, so it's okay to talk about. The U.S. government has a cluster of Cassandra nodes over 400.
Wow! And how's the network topology work in that? Is each machine talking to all other 400, or just the ones nearby, or how does that work?
Yeah, it's a constant time routing algorithm. Each node directly talks to the others, with the special case that when you split it up into, we build the feature for multiple data centers, but really you can use it to group nodes arbitrarily. They don't have to be in different data centers. But if you have nodes in a different group, will communicate with other nodes by they'll pick one node in the group and say, forward this to the other replicas in your group, so that if you have a WAN link where bandwidth is precious, that we're not sending lots of copies of the same data over that link.
And how on the updates that are being distributed to the replicas, is it doing some sort of delta, or does it need to send the whole row again?
It sends whatever updates the client made. So typically deltas, yeah. So this is one of the advantages Cassandra has over databases built around a key value model, where so if I have that user row and I say, update user set email to my new email, I just have to propagate that new email column. I don't have to fetch the whole row, inject the new email, and then write the whole row back out.
That sounds really cool. It sounds very clever. We're running out of time. I just wanted to see if there were anything that I left out of this discussion, that Dan and I left out of this discussion, that you want to make sure our audience knows about.
We're releasing Cassandra 1.0 in early October, and we're having some new features with that. We're releasing compression there. We're doing a lot with read performance there. That's one of the sort of misunderstood things about Cassandra, is that doing high performance reads is relatively easy. When you're dealing with data that fits, your data set fits in memory, or your hot data set fits in memory. So basically everyone can do tens of thousands of reads per second. But to do tens of thousands of writes per second, then you need to go from a storage engine based on random I/O to one based on sequential I/O, which is what Cassandra's log-based storage engine does. Mm-hmm. So somehow the message that Cassandra is really fast at writes got turned into it's fast at writes, but if you have a read-mostly workload, you should use something else, which isn't true. So in 1.0, we're basically going to have reads be about as fast as writes, which is it's 20,000, 30,000 operations per second on a commodity 4-core machine.
Mm. And I was just reminded of one other question. In one of the FAQ answers, you said that you don't believe that memcached is required in front of this. I know every single person I talk to about databases, whether they're big or small or whatever, they always say, oh, we got to have that caching layer in the middle. Why do you think you don't need a memcached in front of this?
Well, there can be a couple reasons. One could be, the big one, the obvious one is for performance, because your database really isn't very fast at reads. The other one is that having memcached in front can kind of hide problems with your database. So if you have a database that takes several minutes to fail over if there's a problem with the master, then having memcached in front can it can hide that from your users as long as they're just doing reads, right? You say, oh, I have that data in memcached, I don't need to hit the database. It doesn't matter that it's busy failing over right now. Right. So Cassandra doesn't need that property because it's designed for high availability from the ground up. Mm-hmm. It actually doesn't need the caching property either, the speed property either, because we can. We have what we call a row cache, where we can hold hot data ready to serve to clients. We basically cut out part of the read path, just like memcached would if you were using that, and we serialize that off of the JVM heap so that we're not bloating the heap there and causing the problems that you have with garbage collection there. We keep it off heap. And you don't have the cache coherency problems that you have with memcached as a separate system. So to explain that briefly, if you have memcached and a database as separate systems, and you send an update to the database, and then the database dies. So I have an update in the database. But my client got an error, so it threw an exception. It didn't put the update in memcached as well. Now my database comes back up. Memcached and the database have different data in them. And so, there's a bunch of ways you can get in that problem of the data in memcached being out of sync with the data. The kind of big hammer that we usually use to deal with that is we just say, okay, memcached, just expire your data every 5 minutes or whatever. So it repopulates it and you're not out of sync you have a bound on how out of sync you can be. But by having the caching layer built into the database, you avoid that problem entirely.
Yeah, I was just thinking as you're describing this, I thought, well, wait, what is memcached actually doing? It's doing that caching for you, and it's also creating problems in that the biggest problem you ever have with a cache is knowing when to blow the cache. And It sounds like what you effectively done is because you have this hot data inside the server directly, inside Cassandra directly, you've got the cache. You've already got it right there, and you know when to blow it because you're right next to the data.
Right.
That's clever. That's very clever. I'm going to have to. I think I've got some people I got to walk over to in a few minutes here at Media Temple and go say, "Hey, we got to go look at this. We can use this for something." I'm sure there's going to be something here that we can use it for. Okay, just to wrap up, I've got to ask my standard questions: VI or Emacs?
Emacs.
Yay! One for eyesight. Yay! And your favorite scripting language? I know I'm not going to like to answer this one already.
Like a lot of people my age, Perl was the first scripting language I used back in '99. But my heart belongs to Python now.
You kids are all like, you crazy kids. It would be, everything would have worked out if it weren't for those meddling Python kids. Well, I really appreciate coming on the show today and describing Cassandra. I know a lot of people's ears perked up during this show, especially in our chat room, about the possibilities for their thing. And I know a lot of people listening at home right now are going, oh my God, there's something that's even better than the other things you talk about with NoSQL. We got to go check this out. So I appreciate you coming on and describing Cassandra for our audience. Thanks for having me on the show. Very good, very good. That was Jonathan Ellis, the current project lead of the Apache Cassandra project and also the CTO and co-founder of DataStax. Dan, what do you think?
Yeah, really fascinating stuff, actually. I mean, I haven't done that much with these NoSQL databases, and as you said, the stuff he was talking about at the end was incredibly clever stuff, and all that memcached stuff that was going on. I think there'll be a lot of people running off to try and have a look at Cassandra now that they've heard this show. I mean, people in the IRC channel are going crazy right now. Yeah, I guess so. Yeah, well, it's good that we can do that. Speaking of the IRC channel, let me talk about upcoming guests. That's the awkward transition for the week. Absolutely. It's funny. I waited way too long before I started booking Q4, and I'll always send out about 30 pieces of email so far. I've only gotten a couple people responded already, and so actually we have nobody scheduled. Well, we have a surprise guest scheduled for the next 5 weeks in a row. I presume by the time we get to next Wednesday, there will be a guest. I just don't know who it is. And also, I'm going to be on a cruise ship, or at least involved with one more of these Insight cruises for the next 3 weeks. So we have a series of very qualified and cool hosts taking over for me. Next week is Aaron Newcomb coming in to host that. You're coming in a couple weeks to be the host. I don't know if you knew that. I just moved you over to the host slot. I did. I just looked, yeah.
and then Aaron's going to come back in for October 12th. But we will have guests. I'll keep sending out email and bugging my friends to try to block that in. And hopefully I'll finish that before I have to travel out to Rome, which will be the next stop after that. But we do have a lot of great people on the short list. We have Moodle, we have Pinax, Vaden. Actually, Pinax just sent me email, so we definitely know we've got them. Pewik, Linux Mint, OpsView, Twisted, Ecalypsis Systems, FreeNAS. Definitely going to get Monty on, Monty Wydenius for MariaDB, along with Kurt Von Fink. They're definitely in there somewhere. I just need to slot them in. TMUX, the Vegas Security Tester, Open Source New York Times. All these guys are on the extremely short list. They just haven't responded to my email about a specific date yet. So you should hear from most of the people I just mentioned sometime coming up in Q4. If you want to find out when we book new guests and add them to the list, you can follow us on both Identica and Twitter at FLOSS Weekly, all one word. You can't follow us on Identica when they're down for 4 days because they're doing a MySQL alter table, but otherwise when they're up, you can follow us on Identica. We also have a blog at flossweekly.posterous.com. We try to post the long versions of the announcements there. We do tape the show, as you might have heard. We're talking to an IRC channel. You can go on this channel by going to live.twit.tv. We are on live at 9:30 a.m. Wednesdays Pacific time. That's U.S. West Coast. Translate that to whatever time is appropriate for you. I still have some Google Plus invites, so I've probably added about 500 people personally to Google Plus now. I do not mind, though. Please, I have an infinite supply of invites apparently, so do not be shy about asking. Google Plus is a great place to hang out. Been doing a lot of interesting things with Google Plus the last few days, especially. Be sure to send me your, I'm going to say it 7 times, and nobody's going to pay attention, gmail.com address. Gmail.com only. Please only send a gmail.com address. I can't take arbitrary addresses there. You can follow me on Merlin, M-E-R-L-Y-N, at both Twitter and Identica. And if you had been following me, you would have known that last Wednesday, although I wasn't on this show, I was docked on the Millennium, Celebrity Millennium in San Francisco. And that evening, we had a meetup at the local karaoke club, the Mint. That was a lot of fun. We had, I think at most about a dozen people. It wasn't a lot of people, but it was great. And Fun Crunch, who hangs out a lot in our online chat room, was there shooting some great pictures. By the way, you should see her Google Plus feed. It's got some good pictures of me even in there. That's hard to do. Also, and you can find out we're also going to be. I'm going to be on a cruise for the next 3 weeks. So again, as I said, I've got guest hosts coming in to take care of things, and right now they're all surprise guests as well. I think that's everything I'm going to plug today. Dan, what can you plug today?
Yeah, I've actually taken your lead. I've got not a big page full of plugs, but I've got a few things I was going to mention. I have to say that when you said I was on the Millennium, docked on the Millennium, and then paused, I really thought you were going to say Falcon. You know? I really thought you were going to say Falcon. Yeah. Anyway, sorry. She made the what is it? So and so run in so many parsecs. Anyway, yeah. So
the Kessel run in less than 12 parsecs. Come on,
that's the one. That's the one. Sorry, I've just destroyed my geek credibility. Yeah. So anyway, this weekend, September the 24th and the 25th, it's PyCon UK. So I think Jonathan might be interested in that one, being a Python guy, although he's not in the UK, I don't think. Yeah, so it's in Coventry, which is in the Midlands in the UK. It's going to be 24th and 25th, and I've been asked to do an after dinner speech, which is going to be interesting because I don't at this point know what I'm going to talk about, but hopefully by Saturday I will. And I'm also going to be taking my guitar and playing live music as well, so that's going to be fun. So if you want to come along, there are still tickets available, I believe. If you go to pyconuk.org, you can find out more about that. There's going to be all kinds of great Python developers there, and me for some reason. So there you go. Also, I want to make a quick note to say check out Rat Hole Radio, which is my music show. I put one up, a new episode up yesterday. And if you're interested in independent music and Creative Commons and stuff like that, you can find that at ratholeradio.org. And that's ratholeradio.org. It's a strange name, but go and check it out if you're into all that. On October the 15th, it's Barcamp Blackpool. There's another Barcamp event coming up. It's in a casino as well, so how cool can you get? So I'll be there for that. So if you can get to Blackpool in the northwest, then you can go to that. And obviously, I think that's probably enough plugs for now. So don't forget to check out all the great shows at Six Gun Productions, including Linux Outlaws and all that kind of stuff. And if you want to find me...
I was just going to say, if you're not going to mention Linux Outlaws, I'm going to have to do it because, like I said, that's a great show for getting all the current news, and you and your studious German are able to sort out all the news of the week.
Yeah, definitely. No, I couldn't leave that out. So don't forget to go and have a look at Linux Outlaws, or have a listen to Linux Outlaws as well. And finally, if you want to catch up with me, you can find me at my username on Twitter and Identica is @MethodDan. That's like the word method and the word Dan shoved together. And also you can find out more at danlynch.org. And I think that's quite enough of a plug fest for now.
Now you're doing an after dinner talk. Are you the gap then? Are you delaying the drinking after dinner so they want your speech to be as short as possible?
I really hope not, yeah, because if I am, I'm going to be very unpopular. If that is the position, maybe I'll just get up and my speech will involve 2 words. Let's drink! That could be quite a good speech.
That could always be it. Well, Dan, as always, I appreciate you coming on, being the co-host for the show, and bringing your unique skills and talents and your own large microphone right there to the video when it's working. I appreciate it very much. Thanks, Dan.
No problem. Thanks for having me.
Very good. And as always, we'll see you all again next week on FLOSS Weekly.